Welcome guys, welcome to my channel once again. This is Electro Teach channel, the channel where we bring you knowledge of electronics, computer, instrumentation and mathematics. Today we want to continue our discussions on electrical circuits, that is DC circuits. So today we are going to check the equivalent resistance of series and parallel circuits, series parallel circuits rather. If you want to know the equivalent resistance of series circuit only, watch this video. And if you want to know the equivalent resistance of parallel circuits, watch this video up. And then you can search the channel and you see those videos and then watch them. But today, I'm going to look at equivalent resistance of series parallel circuits. And we're going to take an example that will help us to understand how this works, understand how to determine currents in a series parallel circuits. So today, I want you to pay more than usual attention. Don't skip any part of this video. Just make sure you watch to the end to get all the necessary steps that we are going to learn. All right. Series parallel circuits. So it's a form of DC circuit where we have series combination of resistances with parallel combination of resistances. So at that instance, we need to determine the equivalent resistance so as to be able to know the total current that will flow from a potential source connected in the circuit. Now, to determine the total current, we need to get one single resistance, which is an equivalent of all the combination of resistances connected. Right now, we are going to use an example. This is the circuit we are going to use as example. So we want to determine the total current that will be supplied from this power source, from this potential source here. I want to know the total current that goes into the circuit. Now, looking at this kind of arrangement, the total current will flow out of this power supply into this resistance, 15 ohms. And that same total current is flowing through this 10 ohm resistance, because those two resistances, they are in series with the power source. But that current is not flowing through 10 ohm here and 10 ohm here. When the current gets into this junction, the total current divides into two. And so we need to determine what flows into each section. So when the total current gets into this junction, it divides into two. We need to determine current in each of these branches. Now we can see this is a good example of a series parallel configuration, series parallel arrangement of resistances. So to start, we need to determine the determine the total equivalent resistance for the four resistances. This. So we could label the resistances with these numbers: R1, R2, R3, R4. Okay, so with that, we want to determine the equivalence by starting from this side, because looking at this right hand side, we realize that the two resistances here, they are connected in parallel. The two of them are linked together in this manner. They are both ends are joined together, one end to the other end to the other two. So we need to determine this. So we need to determine the equivalent of this, and the equivalent of those will now be in series with these two. So we could redraw the circuits to be like this. So what we have here is a resistor R1. This one will be R4. And here we have a combination of R2 and R3 in parallel. So we can write it this way: R2 parallel to R3. And that's what we are going to determine now. So R2 parallel to R3 will be R2, R3 divided by R2 plus R3. And we have 10 ohms and 10 ohms. 10 times 10 divided by 10 plus 10, and that is 100 over 20. That is 5 ohms. So 5 ohms can now be in series with resistor R1 and R4. So the final equivalent resistances can be drawn this way. The final circuits can be drawn this way. And this will be R1 plus R4 plus R2 parallel to R2 parallel to R3. That is it. So we can now determine the final total equivalent resistance. That is R total equals R1 plus R4 plus R2 parallel to R3. And that is R1, 15 ohms, R4, 10. 15 plus 10, then parallel combination of these two is 5. That is 15 plus 10 plus 5. And that is 30 ohms. 30 ohms. So equivalent resistance of this circuit is actually 30 ohms. So this is 30 ohms. 30 ohms. So to determine the total current, having got the total equivalent resistance, we can now determine the total current by applying simple equation. So the total current I can be obtained by I equals V over R. That is R total. And that is 100 divided by 30. That gives us 3.33 ampere. And that is the equivalent resistance, that is the total current in the circuit. Now, if you redraw the circuit once again, we have original circuit this way. So we want to determine also the current in each resistances, as we have explained before. So this is R2, this is R3, this is R1, and this is R4. So the total current I is the current in resistor R1 and R4, as we have explained earlier. But this current is divided into two at this junction. So we need to determine the current in this branch. Let's call it I2, and this is I3, and the total current I is here. So I2, we can use a current divider rule to determine I2. I2 equals I total multiplied by R3 divided by R2 plus R3. And that gives us 3.33 times 10 divided by 10 plus 10. So if you determine this on your calculator, that is 33.33 divided by 20. So we can determine the final answer to that. 33.33 divided by 20. That gives us 1.67 ampere. Now that is actually the current in both R2 and R3, because by calculation this is also equal to I3, because we have equal value of resistances in either of the two branches. So we have 10 ohm here, we have 10 ohm here by the question. So we have 10 ohm here, we have 10 ohm here. So the current will be divided into two equal halves, which is equal to 1.67 ampere. So to determine the total current, you can sum this up or multiply it by 2. Then it gives us the value of the total current again. And that is it. That is how to determine the equivalent resistance of a series parallel network. Series parallel network. Now, this situation, we have two branches in parallel that have equal value of resistances. In many situations, we won't have it that way. We have different value of resistances. And in that case, this formula, which is current divider formula, will be applied. And that will lead us into calculating the current in each branches differently. So instead of saying I2 is equal to I3, we have to calculate I2 separately and I3 separately using this formula. So by current divider rule, what we do is multiply the total current by the resistance of the opposites or the adjoining branch that is in parallel, then divided by the total resistance, summation of the two resistances for two branches in parallel. when we have three branches in parallel, we extend that formula into into that calculation as well. It will not be the same way like this. If you have three branches in parallel, what you do is that you determine two resistances in parallel together, then you make it in parallel with one, then you calculate the current of this one while you use the equivalent resistance of the other two to do this calculation. Then when you finish, you go back to the other two. After getting the current in that branch, then you open the branches into two parallel branches again and still repeat this formula. So I want you to mention at the comment section which other parts of the DC circuits that you would like me to prepare video on, so that I can prepare a video to explain those parts also as I'm preparing other videos. So put your comments down for me. I'll be very glad to see your comment requesting for videos in this DC circuits, in other parts of the DC circuits. So if you haven't done so, please subscribe to this channel and then click the notification bell. And if you are a returning subscriber, thanks for coming back to watch my video. Don't forget to like and share this video. Until another time, I say bye-bye.